All right, here we go. Unit 3, Day 1, factoring when a equals 1. The objective for today is to be able to factor trinomials with a leading coefficient of 1 and identify the zeros of a function. And so we're going to start out, we're going to think about this function f of x equals x squared minus 7x minus 18. And we're going to use that function to talk about why you might want to be able to factor such a function. So let's say we wanted to graph this function and we didn't have Desmos, we wanted to just have an intuitive sense for how we would graph this. An important idea is some of the most important things to graph would be the y-intercept and the x-intercepts of this graph. So where it crosses the y and x axis. The important concepts to realize here are that the y-intercept would be found at the location where x equals 0. And so this is the easier of the two to find. All we'd have to do is find f of 0. So we plug in 0. F of 0 is 0 squared minus 7 times 0 minus 18. All we're left with here is negative 18. And so we know that this graph f of x crosses the y-axis at an x value, at a y value of negative 18, because we just found the point here, 0, comma, negative 18. That is your y-intercept. Now, the x-intercepts are what we're going to be focusing on today. These are also known as the zeros, so that's a really important term here. They're known as the zeros because we want to know when does x squared minus 7x minus 18 equal 0? Because that will tell us when y equals 0, when we are along the x-axis, okay? Because that's where y equals 0. Now, you could just try to plug in a bunch of different numbers. You could plug in 1, then 2, then 3, then 5, then negative 5, then 10. You would eventually find this. But there is a much faster way to find where this graph crosses the x-axis, and that's by factoring. What factoring allows us to do is to put this equation in a form that makes it easier to see when this is true, when it equals 0. And so we'll go over how to factor in a second. I'll quickly talk through it in my head right now. I'm going to split this up into two parentheses because this is a form that I've seen a bunch of times. I know this is going to have x and x to start. And now I'm looking for two numbers that are going to multiply to make negative 18, but add to make negative 7. And I've done this a bunch of times, so I know that these numbers are negative 9 and positive 2. We're going to go over quickly in a second how I did that, but for right now, it's fine that you can just take as proof. Imagine if you did this distribution out. You'd have x times x to get x squared, x times 2 to get plus 2x, negative 9 times x to get minus 9x, and negative 9 times 2 to get negative 18. And so we'd combine our terms in the middle and look, x squared minus 7x minus 18. So that is the correct factoring. Now, the really important idea here is if you know that this f of x is also equal to x minus 9 times x plus 2, and you want to know when does 0 come out, when does this expression equal 0? Well, there's exactly two things that could happen. Either x equals 9, because that would make this first parenthesis 0. You'd have 9 times 11, but who really cares what's in the second one? Once the first one's 0, anything times 0 is 0. Or x equals negative 2. Because if either of those two things are true, one of the two parentheses would be 0, the whole thing would be 0. Just so you can see that real quick, I would normally never do this out. If I plug in 9, we'd have 9 minus 9 times 9 plus 2. That would be 0 times 11. That equals 0. Check. If x was negative 2 minus 9 times negative 2 plus 2, we'd have negative 11 times 0. We'd have 0. Check. So what we just found is that when x is positive 9 or when x is 2, when x is positive 9 or when x is negative 2, that is when our graph touches the x-axis. Now I know that this is a symmetric parabola, so we're going to learn some other ways to find like the vertex of this and so on, but roughly this would help me sketch my graph. I know it looks something like that because it has to be symmetrical. So the vertex is going to be like halfway between those x-intercept values. And so that's why we'd want to do this. Really quickly, here is sort of how we would talk through factoring these. I'm going to go through these examples. They're going to go from hardest to easiest. Sorry, from easiest to hardest. So say we wanted to factor x squared plus 8x plus 12. I need two numbers that multiply to make 12 and add to make 8. We're going to have x, and then I'm trying to figure out what these two numbers are. One thing that you'll see on Delta Math is to like draw an x and just remind yourself, okay, I need two numbers that add to make 12 and multiply to make 8. Well, that's just going to be 6 and 2. So we're going to have x plus 6 times x plus 2. And I could check all this out, right? I could do my distribution here, and I'd have x squared plus 2x plus 6x plus 12. Yes, that's x squared plus 8x plus 12. But when I say factor, all I'm looking for is that. Let's do a couple more increasing difficulty. One more here. Say you go and you start to draw this out. You start to do your factoring. We know these have to be x to make x squared. And what we're looking for is we're looking for two numbers that multiply to make 24 and add to make 10 because they're going to combine in the middle. One thing you can do is you can just start listing the factors of 24. 1 times 24, 2 times 12, 3 times 8. You're going to get better and better at this. 4 times 6. There it is. That's what's going to multiply to make 10. Or sorry, multiply to make 24 and add to make 10. So we're going to have x plus 4 times x plus 6. X times x is x squared. X times 6 is plus 6x. 4 times x is plus 4x. And 4 times 6 is plus 24. See how the numbers multiply? That's why they needed to multiply to make 24. And then they combine in the middle to make 10x. That's why I was looking for two numbers that add to make 10 and multiply to make 24. Now, this looks like it's a typo, but it's not. These get trickier. When we don't have all positive signs here. So what I need now is, let me make it clear this is a separate problem. What I need now is I need two numbers that multiply to make negative 24 but add to make positive 10. So here's what I like to do this one. I like to list the factors of 24. I've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And you're just going to get better and better at this. Eventually you'll do it without drawing the x. Now, if these were both positive, you'd have 1 and 24 add to make 25, 2 and 12 add to make 14, 3 and 8 add to make 11, 4 and 6 add to make 10. But here's the problem. It's not 4 and 6 because one of them has to be negative. So two ways to do this. You can kind of just go down and just pretend these are all negative for a second because they have to multiply to make negative 24. So you'd have negative 1 and 24 make 23. -2 and 12 make 10. So I need -2 and +12. And so we're going to have x minus 2 times x plus 12. And so when this distributes, we'll have x squared plus 12x minus 2x minus 24. See how these are now going to subtract in the middle, x squared plus 10x minus 24. Okay. Now the last one, the one that is usually the trickiest for people, this one sneaks up on you. If I need two numbers that multiply to make positive 15, but add to make 8. This is the one that's really tricky to see the first time. If you need two numbers that multiply to make a positive, but add to make a negative, the only way that's going to happen is if they are both negative. So when I write my factors of 15, 1 times 15 and 3 times 5, it's important to realize these both have to be negative to get -8 in the middle. So what we would have here on our last one is we would have x minus 3 times x minus 5. Just checking this again. The check is just so you can see what's going on. X squared minus 5x minus 3x plus 15. That's x squared minus 8x plus 15.